Hello students, welcome back to Future Foundation. Students, in today's class of basics, we will discuss some questions based on the points we have discussed so far. So let's start. Question 1 is, find the ratio compounded of the subduplicate ratio of 64:9 and the ratio 27:56. So students, in this question we want the compounded ratio or compound ratio of the ratios this and the subduplicate ratio of this. So required ratio will be, we can find the compound ratio by multiplying the given ratios, right? So by taking the square root of 64:9, so root over 64 by 9 into 27 by 56, right? So root over 64 is 8 and root over 9 is 3. So 8 by 3 into 27 by 56. 8 sevens are 56, 3 nines are 27. So required ratio is 7 by 9, right? Now let's come to next question. Next question is, if x plus 7 is to 2 times x plus 14 in the duplicate ratio of 5:8, find x, right? So in question they are saying that the duplicate ratio 5:8 is x plus 7 is to 2 times x plus 14, right? What they are saying, that duplicate ratio of 5:8 means 5 by 8 whole square is equal to x plus 7 upon 2 into x plus 14, right? This is what they are saying in the question. So 25 by 64 is equal to x plus 7 upon 2 into x plus 14. 2 32 is 64. So after cross multiplication it will be 25x plus 350 is equal to 32x plus 224. So 32x minus 25x is 7x is equal to 350 minus 224 is 126. So on dividing by 7 we have x as 18, right? 18 sevens are 126. Now let's come to next question. Question is, if x upon q plus r minus p is equal to y upon r plus p minus q is equal to z upon p plus q minus r, then show that q minus r times x plus r minus p times y plus p minus q times z is equal to 0. So we have to prove this. So students, this question is based on point number 6, which we have discussed in last class or in the last video. What this point says, if we are given a series of ratios, then each ratio will be equal to the sum of the numerators divided by sum of the denominators of the given ratios, right? But in this question we need only two ratios at a time, because QRRP PQ suggests us that we should take two ratios at a time. So now if we are taking two at a time, so let x upon q plus r minus p is equal to y upon r plus p minus q. So it will be also equal to x plus y upon 2r, right? Okay. Similarly, y upon r plus p minus q is equal to z upon p plus q minus r, which is equal to y plus z upon 2p, right? And x upon q plus r minus p is equal to z upon p plus q minus r, which can be written as x plus z upon 2q, right? But as these ratios are also equal, so x plus y upon 2r must be equal to y plus z upon 2p is equal to x plus z upon 2q, right? Or this can be written as x plus y upon r is equal to y plus z upon p is equal to x plus z upon q. So it is lambda, right? Now from LHS, that is q minus r times x plus r minus p times y plus p minus q times z, right? I am writing this in other form, that is if I expand this, that is qx minus rx plus ry minus py plus pz minus qz. So if I separate pq and r terms, it is q and q. So I'm taking q as common, so it will be q times x minus z. Similarly, I'm taking r common, so r times y minus x plus p times z minus y. Okay, now in place of q I can write x plus z by lambda and x minus z as it is, plus in place of r I can write y plus x by lambda into y minus x as it is, plus in place of p I'm writing z plus y by lambda and z minus y as it is, right? Now I'm taking 1 by lambda common, and inside bracket it will be x square minus z square plus y square minus x square plus z square minus y square. Okay, so 1 by lambda into 0, which is 0, and it is RH, right? Hence proved. So sometimes we need to take two ratios at a time, right? Now let us take one more question. Question is, if y upon x minus z is equal to y plus x upon z is equal to x upon y, find the ratio of x is to y is to z. Okay, students, so now in this time I'm taking all three ratios. So y upon x minus z is equal to y plus x upon z is equal to x upon y. Now adding all three numerators and all three denominators, and it will be equal to 2 times x plus y upon x plus y. So y upon x minus z is equal to y plus x upon z is equal to x upon y is equal to 2, right? Now by taking 2 at a time, so y is equal to 2x minus 2z and y plus x is equal to 2z, right? So on adding, I am taking y upon x minus z is equal to 2 and y plus x upon z is equal to 2, and from this I am making I have made two equations, and now I am solving two equations, or I am adding these two equations. So this is 2y plus x is equal to 2x, or 2y is equal to x. What I am doing right now, I am making relation, right, in x, y and z. So similarly, if I am using these two, then y plus x is equal to 2z and x is equal to 2y. So on adding, y plus 2x is equal to 2z plus 2y. So 2y is nothing but x. So this is x by 2 plus 2x is equal to 2z plus x, right? So it is 3 by 2x is equal to 2z. Okay. Now if y is equal to lambda, then x is equal to 2 lambda and z is equal to 3 by 4 into 2 lambda, right? Means z is equal to 3 by 2 lambda. Okay. So I'm making lambda on one side. So lambda is equal to x by 2, and from here lambda is equal to 2z by 3. So therefore x by 2 is equal to y is equal to 2z by 3, or if I divide by 2, then it will become x by 4 is equal to y by 2 is equal to z by 3, right? Which is required ratio. So students, let's meet in next video. Till then, bye bye and take care.